Linear functions, domain and range introduction to linear function, and illustrate linear function. We're going to review what do you mean by relations and what is the connections of relation to linear functions. So these relations, we have the set of ordered pairs, the samples 1 and 2. And this is a domain or input. We can say that is the first set of the coordinates or x. And this is the range, the output, the set of the second coordinates or y. We can say that its function if the domain has one element correspond to range. So we can say that these functions can be tested as vertical line tests in graphical presentation if there's only one point intersects of vertical line. So meaning you have to see the intersections of one point only when you use the vertical line test. So this is a graph of examples of functions, and this one is a function, and another one function. And we can say that y depends on x. Remember the variables, so we're going to use that as in domain and range. For example, the equation y equals to x plus 5. If you assign x equals to 3, the value of y equals 11. So the x equals to 3, that is a domain, and the range is y equals to 11. Example number 1, determine the values of the function f if f of x, this is how to read this one, f of x equals to x minus 1 at x equals minus 3, 0, or negative 3, 0, and 2. Give the ordered pairs, identify the domain and range. So this is the first solutions. The first solutions we're going to write first given. If x equals to negative 3, then f of x equals to x minus 1. And then we're going to substitute the x to the 3. So we're going to say this is f of negative 3 equals 2 times negative 3 minus 1. So we're going to multiply 2 times negative 3. So we have this, just copy this one and just multiply again, negative 6, and copy negative 1. And then we're going to combine this negative 6 and negative 1. So it becomes negative 7. Therefore, if x equals to negative 3, then y equals to negative 7. Then let's write the ordered pair, negative 3 and negative 7. All right, let's go to this next solution. So we have f x equals to 2, then f of x equals to 2x minus 1. Again, we're going to substitute. F of 2 equals 2 times 2 minus 1. So substitute for this one and substitute for this one because we have the x and x here. Now multiply 2 times 2. So this becomes f of 2 equals 4 minus 1. So 4 minus 1 is 3. So now we're going to get this one. If x equals to 2, then y equals to 3. So this is the results to y, or we can say this is the range and this is the domain. And then the pairing, this gives the ordered pair 2 and 3. And next solutions, f of x equals to x minus 1. Then we're going to substitute the 0. So it becomes this one, f of 0 equals 2 times 0 minus 1. Thus it becomes 0 minus 1, and then the range is negative 1. Then if x equals to 0, then y equals to negative 1. And this is the ordered pair, 0 and negative 1. Now we're going to identify the domain and range. We're done for the ordered pairs. These are the ordered pairs. And now, this is the domain. So we're going to write this according to the number line. So the number line must be the negative 3 must be the first one. So these are the domain. Negative 3, 0, and 2. And range is negative 7, negative 1, and 3. Now after that, we're going to graph. So these are the graph. So let's graph first the 2 and 3. So how to graph again? So this is the positive of x here. Going to count 1 and 2, and then going up 3 times 1, 2, 3. So therefore that is the point. Another one, the 0, -1. And the other one, 3, -3, and -7. So the -3, -7. So we have the ordered pairs here, all up here, and you're going to connect it to line. So that's it. So this is the graphs. Example number 2, determine the values of the function f if f of x equals to 2 minus 3x at x equals to -1, 0, and 1. Give their ordered pairs. Identify the domain and range. So let's have the solution for number 1. If x equals to -1, then f of x equals 2 minus 3x. Then it becomes like this one. So we're going to substitute the x as -1. You're going to substitute the -1 to x. So that's the clarifications. If f of -1 equals 2 minus 3 times a -1, so we're going to multiply this one. So it becomes a positive 3. According to the law of the integers, is both negative. We're going to multiply, so it means that's positive. Then we have 2 plus 3 is 5. And so this is the range 5 and the domain is -1. So the ordered pair is -1 and 5. And another solution is if x equals to 0. So it becomes this one. So we go to substitute again the 0 here and here. And then the 2 minus 0. 3 times 0 is 0. So 2 minus 0 is 2. So therefore, so this is the x and this is the y. And the ordered pair is 0 and 2. So solutions again. So x equals to 1. Then we have going to substitute 1 here and 1 here. And then 2 minus 3. How does it become 2 minus 3? 3 times 1 is -3. So we have the sign also here. And 2 minus 3 is -1. According to the law of integers, if this one is negative and this is positive, we're going to subtract and copy the signs of the higher number. Or this is subtractions, right? So we're going to change the sign and same with the subtractions. Change the signs, it's -3, then proceed to the addition, it's the same answer, -1. And then this is the x and y, and the ordered pair is 1 and -1. Now the domain and the range. The domain is -1, 0, and 1, and the range is -1, 2, and 5. Are we going to graph? So this is -1 and 5, and this is 0 and 2, and 1 and -1. Then connect the line. So that's it. Next activity. You're going to determine the values of the function f if f of x equals -3x minus 4 at x equals -3 or -3, 1, and 2. Give their ordered pairs and the domain and the range. So we have the solutions again and again. So x equals to -3. Then we're going to substitute. So -3 times -3 is +9. So it's this one. So 9 minus 4 is 5. So the range is 5 and the domain is -3. So the pair here is -3 and 5. And then another one, if x equals to 1, and then we have the -3 times 1, and then we have -3 and -7. So why is it -7? So -3 and -4 is both negative. We have to add and copy the sign. And then this is the pairing. Okay, 1 and -7. Another one is the x equals to 2. So -3 times 2, we're going to substitute also here. The -3 times 2 is -6. Then both negative, we have to add and copy the signs. And this is a pairing, 2 and -10. Now identify the domain and range. So the domain is -3, 1, and 2. So this is the domain, -3, -1, and 2. Okay, and the range is -10, -7, and 5. And this is the graph, -3 and 5, and 1 and -7, and 2 and -10, then connect a line. Illustrating a linear function. A function is a linear function if and only if its equation can be written in the form y equals mx plus b, or f of x equals mx plus b, where m is a slope and b is a y-intercept of the line. The graph is no vertical straight line. So let's have the example. Is y plus 2x equals to a linear function? This is the graph, and we can show it the solutions. So for y, we're going to equate this one into y equals mx plus b in the slope-intercept form. So this is in the form of ax plus by equals c. To equate this, we have to make sure that we're going to use the property of equations. So -2x, so we're going to add -2x to both sides of the equations, or we can say that is a subtraction property of equations. And then what happens to the next? The equation is now in the form of y equals mx plus b. So this one can be cancelled, and this one is the new form for y equals mx plus b. And we can say this f of x equals -2x plus 2. So we can say, so this is the linear function. So we can say yes. Example number 2. Is x squared -y plus 1 equals 0 a linear functions? But anyway, as you can see the equations here, we have the exponent 2. So therefore, if we have the exponent 2, that's not a linear function, because we can say linear function is we have the power or the degree of 1. So since we can see here the degree of 2, so that is a linear function. But anyway, we can see the graph was that. And the graph is like that. So this is called the quadratic equation. And we can say the solve for y, and then add -x squared and -1 to both sides of the equations, and then we're going to do the complicated equations, but it's the same answer for this one. We have x squared plus 1. But anyway, we can say, so this is not the linear equation, so you can say that's no linear function. Example number 3 is y quantity x plus 6 equals x quantity y plus 3 are linear functions. So this is the graph. So we're going to make sure we're going to do the y equals mx plus b. So using the distributive property, we can say that we have this xy plus 6y equals xy plus 3x. And then we're going to use the subtraction property. Just add -xy to both sides of the equations. And then, so that becomes 6y equals 3x. And then apply the division property of equality, and we can say multiplication property of equality. So we have y equals 1/2 x. So therefore, f of x equals to 1/2 x. So what about the 0 here? The y-intercept here. So the b is 0, so it means the y-intercept here is 0. So that's not affected of the y equals mx plus b. So just be sure we have here the value for, I'm going to substitute the value for x. So it means that is the linear equations. So it is linear functions. So say yes. Now let's add the activity. Determine whether the given equation or graph is a linear function or not linear functions. Let's have number 1. Y equals 5x plus 1. So therefore, there's we have the mx and plus b. And so for number 2, I'm going to put it all the given. So let's have the number 1. So that is linear function. How about the number 2? We have the x squared, and the degree is 2. So therefore, that's not linear function. We have here the m, but there's no value for b or the y-intercepts. Therefore, the y-intercept here is 0. So it's automatic that is linear functions. And this graph is for the quadratic equation. So this is not linear function. And this one, if we go to test the vertical line test here, so it means we have linear function. Then for number 6, look at out. So like we said before, the illustrating linear functions, non-graphical, a straight line of the graph. But this one, as you can see, the straight vertical line. So this is not linear function.